All right, guys, sampling methods. And we will study 4 basic sampling methods that can be used to obtain a representative sample: random, systematic, stratified, and cluster. And these are also known as probability sampling. When you take research methods, especially at the graduate level, if you plan to go to graduate school, you're going to learn the difference between probability sampling and non-probability sampling. And these are 4 basic types of probability sampling. So what I'm going to do is I'm going to explain each type of sampling, and then I'm going to draw a diagram that represents the type of sampling that I'm focusing on. So a random sample. Each subject of the population must have an equal chance of being selected. Here's our population. I'm going to draw a box here. Let's say there's 500 people inside of it. 500 subjects. And I want to choose 20. Right? That means out of the 500 subjects that are inside of my population, I am picking 20. And each person has a chance of being selected. So that is an example of random sampling. So I pick 20 people. I pick one from here, 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 here. Each one has an equal chance of being selected. These 20 dots represent, if I drew 20 dots, I lost count, represent my sample. I'll take them from the population. And I will include them a part of my sample, which is a subset of the population. Now, when it comes to systematic sampling, right? It says taking by a number in each member of the population. Well, it says taken by numbering each member of the population, and then selecting every kth member where k is a natural number. So let's draw my population. I'm gonna keep it small, short and sweet in this case. So what we're going to do is we're going to number each member of the population. Let's say there's 25 people here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. Right? So we numbered each member of the population. And then in this case, I'm going to select every fifth. Well, actually, let's do every fourth member. Every fourth person is selected. So we count 1, 2, 3, 4. That person selected. So 1, 2, 3, 4. 1, 2, 3, 4. So the fourth person selected. Then again, we count up by 4s again. We're selecting every fourth person. After that, we're selecting every fourth person. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Every fourth person is selected to be a part of my sample. So my sample will consist of the 4th person, the 8th person, the 12th person, the 16th person, the 20th person, and the 24th person. Because I counted up by 4s, multiples of 4. And that's my sample. Write that better. Okay. Now, let's transition on to stratified sampling. It says stratified sampling. When a population is divided into groups where the members of each group have similar characteristics and the members are chosen from each group at random. Okay. So we're going to draw a population again. Let's say there are 300 people in this population. What I want to do is I want to divide the group based on a similar characteristic. So I'm going to divide the group into based on year in college for undergrads. So the characteristic is going to be year in college. College year. Because that's a characteristic that we each, well, those who are in college has. So you have a freshman, you have sophomore, you have juniors, you have seniors, right? And then after that, what I'm going to do is I'm going to choose 25 people at random from each group. Right? So that means I'm picking, for my sample, I'm picking 25 freshmen. I'm picking 25 sophomores. I'm picking 25 juniors. I'm picking 25 seniors. And that's my sample. Divided based on a characteristic, then selected at random 25 from each of those groups. And also, I want to mention here that it doesn't have to be the same number from every group. It could have been 25 freshmen, 20 sophomores, 30 juniors, and 20 seniors, right? And also, when I divide my group, my 300 people, I don't mean that 75 is a part of each group, because 1/4 of 375, there can be 80 freshmen in total, 60 seniors, 30 juniors, and the rest of them could be sophomores. So it doesn't have to be what happened to my screen? It doesn't have to be just one value, or the same value for every group, every subgroup. And last but not least, cluster sampling. So what I'm going to do is, here, read the definition. Cluster sampling, existing groups of subjects that represents a population is used for a sample. The population is divided according to subgroups, and a specific number of subgroups are selected using all the members. So when it comes to cluster sampling, we usually go based on a geographical location. So let's say here's my population. Here is my city. And let's say the city has 5,000 people in total. And the city is divided up on 10 zip codes. So Z1, Z2, Z3, Z4, Z5, Z6. And when I say Z, I'm representing zip codes. So Z means zip code. Z7, Z8, Z9, Z10, right? So it's based on existing groups, which is, zip codes. And then out of that, right, I'm going to pick 4 groups at random. So I'm picking Z1, Z7, Z3, and Z10. And when I pick all my zip codes, I'm using all the members in those zip codes. So that means whoever is inside of zip code 1, if you live in zip code 1, all the members are chosen. Those in zip code 3, chosen. 7, chosen. 10, they're chosen. So all those members who lives in those zip codes are part of my sample. And that's cluster sampling. All right, guys. These are the different definitions of sampling. Take them down, draw the diagram. Hopefully the diagram did help for you to determine how to evaluate each type of sampling. What you can do is you can start answering these questions here, A, B, C, and D. And in the next video, I'll go over the solutions to these questions. So screenshot it, take it down, write it down, determine what kind of sampling it is based on the 4 types that I did here. If it's random, if it's systematic, if it's stratified, and if it's clustered. See you soon.